Okay, we are going to talk today about writing exponential equations through 2 points. So we're going to do two different examples. The first one is going to be a specific example when we have the y-intercept. So we're going to start here on top by saying the y-intercept is given. And then our example is going to be the point 0, 4 and 3, 500. Okay, so the first thing we need to do is we need to figure out first what is our exponential equation. So our exponential equation for this is going to be y equals ab to the x power. And if we look at the points, we know some information. So I specifically gave you our a value. So this first guy here is our y-intercept, which is another word for our a. And then we also know a point. So we know that this is our x value, and then the 500 would be our y value. So what we're going to do now is we're going to plug into this equation all of the information that we know. So we know our y value is 500, so we're going to do 500 equals, a is 4, we don't know what b is, and we know x is 3. And then we're going to use our algebra skills to solve for b. So our first step would be to divide by 4 to get that b cubed all by itself. So 500 divided by 4 gives us 125. Okay, and then finally to get b by itself, we need to take the cube root of both sides to get rid of that cubed power. So it gives us b on the right-hand side, and then the cube root of 125 is 5. Which then leaves us with enough information to write our equation. So our equation is y equals 4 times 5 to the x power. So before we're done, we are going to, off to the side, list our steps. So we have step number 1. We would fill in 4 for our a value, 3 for x, and 500 for y. Okay, so that's how we got this first equation. Okay, then step number 2, we started solving. So step number 2 is right here. So we divided by 4. And the reason we did that was to isolate our b value. Okay, then step 3, we took the cube root to isolate the b again. And then last step, so step 4, is write that equation. Okay, so this top one I want you guys to put a star by. So this is only going to work if we know that y-intercept value or that a value. So the next one that we're going to do is going to be a process that's going to work always. So if you're going to remember one of the two methods here, I would recommend working with the second one. It will work regardless of having the y-intercept or not. So for our second example here, we are going to just label this with no y-intercept given. And then our 2 points are going to be the point -1, 384, and 2, 6. Okay, so this time I am going to write our work and our steps at the same time so that we can kind of keep track of what we're doing because it does get a little bit tricky here. So our first step is actually going to be the same as the first step in the last one, is we are going to fill in x and y to create two systems. So we have 2 points here, so we can fill in x and y twice. So off to the side, I'm just going to remind us, here is our exponential equation. Okay, and the only trick here that you need to make sure you're doing is you have to make sure you start with the bigger x value. So because 2 is bigger than -1, we are going to go ahead and start with that 2. So I'm going to label this with an x and a y, and that's going to form our first equation. So 6 equals a times b to the second. And then we're going to use our second equation. So we have, again, xy, not our second equation, I'm sorry, our second point. So we have x and y. So again, we're going to plug it in here. So 384 equals a times b to the -1st power. So again, our first step is to fill in x and y to create a system of equations. And then we want to make sure we start with the bigger x. Okay, so now comes the tricky part. So now what we need to do is we need to solve this system. So because we have multiplication going on over here, we are going to use the operation that undoes multiplication. So to undo multiplication, we are going to go ahead and divide these two equations. So step 2, we are going to divide the two equations. Okay, so in your calculator, you can do 6 divided by 384. And let me show you how that works. So we have, if we can see it, 6 divided by 384, which gives us a decimal. If we go into math, and then that arrow fraction means turn our answer into a fraction. So our fraction is 1/64. When we're working with exponential equations, I would highly recommend always trying to get your fraction. That way you're not rounding. Okay, and then on the other side of the equation, we have a divided by a. So something divided by itself cancels out and gives us a 1. And then we have b squared divided by b to the -2nd. So this problem here is why exponent rules have become so important. So when we're dividing the bases, we need to subtract our exponents. So we're going to do 2 minus -1, which gives us 3. So we have b to the 3rd power. Okay, so over here, we're just going to add some notes here. So we're going to divide the two equations. It eliminates a. And then we're going to make sure you subtract the exponents. Had to squeeze that in a little bit, sorry. Okay, then our next step is going to be to solve for b. So in order to solve for b, we need to get rid of that 3rd power. So we are going to take the 3rd root. And since I have my calculator right here, I will show you how to do that. So we hit math. We go down to the cube root, so number 4. And then 1 divided by 64. And so you can either use the decimal 0.25 or go in and change that into a fraction, which is 1/4. Okay, so now we know our b value. So now we need to go back and solve for a. So we are going to plug b into one of those equations. To find our a value. So I'm going to always use the one with the positive exponent. So I'm going to use that top one. We have 6 equals a times 1/4 squared. Okay, so we have 6 equals a times 1/16. Okay, here we square top and bottom. And then you can either divide by 1/16 or you can multiply both sides by 16. And you should get that a is 96. Which leads us to our very last step. So step 5 is to write the equation. So we have y equals 96 times 1/4 to the x power.